A rocket taller than a 20-story building blasts into space with millions of pounds of thrust. Just minutes later, that same rocket is falling back toward Earth at incredible speed. Now, imagine trying to land it, not on a runway, not on solid ground, but on a small ship floating in the middle of the ocean. It sounds impossible. Yet today, rockets do exactly that, with astonishing precision. How can a machine falling from the edge of space hit a target that's constantly moving with the waves? How does it stay perfectly balanced, slow down at exactly the right moment, and touch down without tipping over? The answer is one of the greatest engineering achievements of the modern age. And once you understand how it works, you'll never watch a rocket launch the same way again. For decades, rockets followed a simple rule: launch once, complete the mission, then fall into the ocean, or burn up in the atmosphere. It worked, but it came with a huge problem. Every launch destroyed a machine that cost millions of dollars to build. Imagine buying a brand new passenger airplane, flying it across the country just one time, then throwing it away. That's exactly how space travel worked for more than half a century. It was incredibly expensive, incredibly wasteful, and impossible to scale for the future. Engineers knew there had to be a better way. The solution wasn't just to build bigger rockets, it was to bring them back, safely, and fly them again. That idea sounded almost impossible, because landing a rocket is far more difficult than launching one, and landing it on a moving ship in the middle of the ocean takes the challenge to an entirely different level. When a rocket launches, it doesn't stay together forever. Most modern launch vehicles have multiple stages. The first stage does the hardest work. It lifts the entire rocket off the ground and pushes it through the thickest part of Earth's atmosphere. In just a few minutes, it burns thousands of gallons of fuel and accelerates the vehicle to incredible speeds. Once its job is finished, the first stage separates from the rest of the rocket. Traditionally, that booster would fall into the ocean and be lost forever. But modern reusable rockets are designed differently. Instead of becoming scrap metal at the bottom of the sea, they begin an incredible journey back to Earth. Not by parachute, not by gliding, but by flying themselves. At first, landing a rocket on solid ground might seem like the obvious choice. After all, runways don't move, neither does the ground. So why would engineers choose to land a multi-million-dollar rocket on a ship floating in the middle of the ocean? The answer begins long before the rocket ever returns to Earth. Not every mission follows the same flight path. Many satellites need to reach orbits that require the rocket to travel hundreds of miles away from the launch site. By the time the first stage booster separates, it's often too far from land to safely turn around. Flying all the way back would require much more fuel, and every extra pound of fuel means less room for the satellite or cargo riding into space. Instead, engineers place an autonomous drone ship directly beneath the rocket's return path. The rocket doesn't have to fly back across an entire coastline. It simply lands where physics naturally brings it. This saves fuel, increases payload capacity, and makes missions far more efficient. Sometimes, the smartest solution isn't changing the rocket, it's changing where the rocket lands. Landing on the ocean creates an entirely new challenge. Unlike a concrete landing pad, the sea is never still. Powerful waves constantly lift, lower, and tilt the ship. Ocean currents slowly push it away from its original position. Strong winds can change direction without warning. Even on calm days, the landing platform is always moving. So how can a rocket hit a target that refuses to stay still? The answer lies inside the drone ship itself. Although it has no crew during landing operations, it isn't drifting freely across the ocean. Hidden beneath its deck are powerful computer systems connected to multiple GPS receivers, gyroscopes, accelerometers, and precision navigation equipment. Large thrusters mounted around the ship continuously push against the water. Every second, they automatically adjust their power to keep the platform almost perfectly centered. This technology is called dynamic positioning. Instead of dropping an anchor, the ship constantly fights the ocean to remain exactly where it's supposed to be. Even while the sea keeps moving, the landing target barely changes position. Without this remarkable system, precision rocket landings simply wouldn't be possible. By the time the booster begins its descent, it's still traveling at incredible speed. Every gust of wind, every tiny change in air pressure, and every second of flight can alter its path. To stay on course, the rocket constantly measures its own position using GPS, onboard sensors, inertial navigation systems, and powerful flight computers. These computers perform thousands of calculations every second. They compare the rocket's exact location with the ship's exact location. Then they predict where both will be moments later. Instead of reacting at the last second, the rocket is always planning ahead. If a crosswind pushes it slightly to one side, the guidance system immediately corrects the trajectory. If the ship moves with the waves, the landing path changes as well. Everything happens automatically. There isn't a pilot sitting inside making these decisions. The rocket flies itself, and it does so with astonishing accuracy. But guiding the rocket toward the ship is only part of the challenge. The hardest part is still ahead. As the booster falls through the atmosphere, it's still traveling at hundreds of miles per hour. To land safely, it must slow down with extraordinary precision. At exactly the right moment, the rocket's main engine ignites once again. A brilliant column of fire erupts beneath the booster. This is known as the landing burn. Unlike the launch, where maximum thrust is needed to escape Earth's gravity, the landing burn does the exact opposite. It carefully reduces the rocket's speed until it's descending at just the right rate. Every fraction of a second matters. If the engine starts too early, the rocket could run out of fuel before reaching the deck. If it starts too late, the booster would strike the ship with catastrophic force. To avoid that, the onboard flight computer continuously calculates the rocket's speed, altitude, direction, and distance from the landing pad. It also accounts for wind, air density, and the slight movement of the drone ship below. Thousands of calculations are performed every second. Just moments before touchdown, 4 landing legs deploy from the base of the booster. The engine makes its final adjustments, and the rocket gently settles onto the center of the landing platform. Within seconds, a vehicle that had traveled to the edge of space is standing perfectly upright on a ship in the middle of the ocean. It's one of the most precise landings ever achieved by any machine. Landing a rocket on a moving ship isn't just an engineering milestone, it's a completely new way of thinking about space travel. For decades, rockets were built to fly only once. After every mission, the most expensive part of the vehicle was lost forever. Today, that same booster can return safely, be inspected, refueled, and fly again. Reusability has dramatically reduced the cost of launching into space and made more frequent missions possible. It has transformed what was once considered science fiction into an everyday reality. The next time you watch a rocket lift off, remember that reaching space is only half the mission. The real challenge begins on the journey home. A rocket must guide itself through the atmosphere, slow itself from incredible speeds, and land on a floating platform no larger than a football field, all without a human pilot on board. That isn't luck. It isn't magic. It's the result of decades of scientific discovery, advanced engineering, and some of the most sophisticated computer systems ever built. And as rockets become even more reusable, this remarkable technology is opening the door to a future where missions to the Moon, Mars, and beyond become more achievable than ever before. The future of space exploration won't just depend on reaching the stars, it will depend on bringing the rocket home. But here's something to think about. If we can land a rocket on a moving ship in the middle of the ocean, what engineering challenge do you think humanity will solve next? Let us know in the comments.